Hi everyone. This is the video reteach of how gases behave. So talking about real versus ideal gases and Graham's law. We're going to start off with the kinetic molecular theory because it's related to this real versus ideal question. So the kinetic molecular theory is basically, in theory, how gases behave. Now, no gas follows this perfectly. And so we say gases that are closer to following it, gases that behave like ideal gases, follow these assumptions more closely than gases that are behaving like real gases. So ideal gases are following these assumptions more closely than real gases. Okay, so what are these assumptions? The first one says that particles that make up gases can exist as single atoms or as molecules, but they behave like spheres either way. So even if they've got a shape, there aren't very many molecules, just atoms that are perfect spheres. So there aren't very many molecules that are spheres, but the ones that aren't, they're still behaving like spheres, is what this is saying. Number two, particles of all types of matter, including gases, are in constant motion. Even particles in solids are still in constant motion. Motion doesn't stop until we get to the theoretical temperature of absolute zero, which we've never been able to do. So all types of particles are in constant motion. Gas particles move in straight lines until they collide with another particle or a wall. So they can't just change direction without hitting something. Number four, gas particles experience elastic collisions, and elastic means that energy is not lost. So the energy total before and after the collision is the same. Number five, gas particles do not stick to other particles. They have no attractive or repulsive forces. And lastly, gas particles have no volume, but are points in space. So these are the assumptions that we make about how gases behave, and ideal gases follow these pretty well. Okay, so let's read real versus ideal gases. It says, no gas particles behave perfectly ideally, but some gases behave more ideally than others, and some conditions, like temperature and pressure, make every gas behave more ideally than other conditions. Okay, so this is what we were talking about before. Gases that are close to the assumptions of the ideal gases will behave more ideally than gases that are further from those assumptions. For example, one of the assumptions of ideal gases is that particles take up no space at all. Therefore, gases that are made up of molecules that are smaller or lighter will behave more ideally than gases made up of bigger and heavier molecules. So think back to when we did this example where we had the BBs and the Play-Doh. We talked about how the BBs would represent a more ideal gas than the Play-Doh because the BBs, and go ahead and take some of these out, the BBs are smaller and the real gas particles are bigger, right? So which one of these is closer to the assumption that gas particles have no volume? Well, these are closer to having no volume than these because these are so big. And so these would be more ideal than these, okay? Oh, whoops, lost one. Okay, let's keep reading. Okay, for another example, think about the assumption that ideal gas molecules have no attraction to or interaction with each other. Therefore, gases made up of nonpolar molecules, which do not attract each other, will behave more ideally than gases made up of polar molecules, which do attract each other. Okay, so again, your ideal gas particles, they don't stick together, but more real gas particles that aren't following the assumption that they don't stick together, they will stick together. And what makes molecules stick together is them being polar. And so when you have a polar molecule, it's going to act more like a real gas, and it's going to because some of those molecules are going to stick together because they're polar. So being polar makes it act more real. Being big makes it act more real. Being nonpolar makes it act more ideal. Being being smaller makes it act more ideal because it's closer to these assumptions. Okay, let's keep going. Finally, the conditions under which gases behave most ideally are low pressure and high temperature. And you can remember that because those are the conditions under which, at least I like to work. Low pressure, not too much stress, and high temperature, I don't like to be freezing cold. Okay, and let's move on now to how gases move. So Graham's law says that lighter gas particles move faster than heavier gas particles, okay, at a given temperature. And then we've got these two terms. One is a gas escaping from a small hole in a container, so that's going to be a fusion. I remember a fusion, escaping, they both start with an E. It's escaping from a tiny hole. And then diffusion is the spreading out of gas to fill the space that it's in. Okay? And lastly, you need to know that gases always move from areas of high pressure to areas of low pressure. Okay, go ahead and start the guided practice.